Welcome to my YouTube channel. This is where we do mathematics. Today we are going to look at a very interesting grade 9 topic 2, which of course it is repeatedly in grade 10 as well. So now today our main focus will be index notation. Index notation lesson number 1. So before we talk of this video, I would advise you to subscribe on my YouTube channel, do like and comment where necessary, and follow the videos by the lesson number. That is how you are going to find these videos or lesson effective. But if you jump a number, a lesson, let's say this is lesson number 1 of index notation, and you go and watch lesson number 3, then it means that you will not have the full understanding of index notation. So today let us much focus on lesson number 1, index notation. So what is index notation? That is a question that should be asked by any pupil. What is index notation? We are simply saying that the expression a to the power m, this kind of expression, okay, where this a and m are real numbers. You know what real numbers are? Okay, these are real numbers. And a, meaning this a which is here, it is not equal to 0, and a again is not equal to 1. Hence, this is what we call index notation. So in a short way, we are simply saying index notation, it is an expression whereby a and m, these are there is a power and there is also a real number. Now this real number, which is a, should not be equal to 1 raised to any power and should not be equal to 0 raised to any power. Because if you do that, then it means that that will not have any grand meaning. What it is simply like this. Look at this a which is here. This a, it is simply called the base. Okay, this a is simply called the base. It can be any number apart from 1 and 0. Okay, it can be 2, 3, 4, 5, 6. Any number apart from 0. And this m which is here, it is an index of power. This power can be any number including 0. It can be 0, it can be 1, it can be 3, it can be 4, any number. Okay, so here that is what the index notation, this is how it looks like. When you see a question coming like this, just know that this is index notation and our indices. Okay, so now how can I further explain this? For example, what this statement is that a should not be equal to 0 and a should not be equal to 1. This a, it simply means that if you put a to be 0, it won't have any meaning. For example, let's have 0 raised to any index or raised to any power. Raise 0 to any power, let's say maybe 10. My answer for this one should be 0. Raise 0 to power, maybe let's say 20. My answer to this one should be 0. You see that? So there's no meaning to this one. And again, when we say let us raise 1 to power 2, my answer should be 1. Let us raise 1 to power 100. My answer should be 1. You see also this and this, they have no meaning. So we are simply saying in index notation, we should not have a situation where the base is equal to 0 and also the base is equal to 1. Hence, if it is like that, you are not going to make any meaning. That is how you can also understand the index notation. Now let us come to the positive index now. The positive index, you know, the index is the power. So we are simply talking of the power which is a positive one, not a negative power, but a positive one. When we go to grade 10, we shall definitely look at the negative index as well. But for now, in grade 9, we shall only focus on positive index. Now, given an index notation, a to power m, this is the index notation given, where m is a positive index. Remember, m is a power. This m simply stands for the power, or you can say index. Where m is a positive integer. Integer simply means any number. It can be a negative 0. It can be integers. We have 0, 1, 2, 3, 0, negative 1, negative. Those are integers. So now they're saying that this m can be any number or any integer. Now in this scenario, the integer that we are focusing in is the positive one, which can be 0, 1, 2, 3, 4, 5, 6, 2, or whatever number you want. Then we have a situation like this one. If I have this a, remember this a, you can put it to be any number. If a is raised to power m, therefore it simply means that this a I should multiply it by itself m times. Let's say that if I have this a to be a number, let's say a to power 2, this simply means that I need to multiply this a 2 times by itself. So we are saying a times a. As you can see, it has multiplied itself 2 times. This is what they mean by this kind of a concept here. That is index notation. Let's look at the example here. The example simply says evaluate 3 to power 4. What are they simply saying here? So let us have our solution just here. Solution. So they are simply saying we should evaluate 3 to power 4. So the way to evaluate 3 to power 4, they are simply saying that this 3 should multiply itself 4 times. Then it means that you are doing the needful. So now we are simply saying this is going to be 3 times 3 times 3 times 3. How many times? 1, 2, 3, 4. That is what they are simply telling us. Once we multiply these 3 4 times, then we can easily find our answer by simply saying what is 3 times 3? We have 9. Okay, 3 times 3 we have 9 times 3 times 3 we have 9. Now what is 9 times 9, which is 81. You see that? Like this, now we have worked out this kind of equation. Evaluate 3 to power 4. So this is how you do it. We are simply saying that this 3 should multiply itself 4 times. Don't make a mistake that most pupils make when you are given 3 to power 4. They just say 3 times 4. Once you do this, then it means that your answer is meaningless and you are wrong. So this, what it means is that 3 should multiply itself 4 times. If you have been given 5, meaning 3 should multiply it by itself 5 times. Meaning if 3 should multiply by itself 20 times, just like that. Don't multiply 3 times 4 and say that I'm doing index notation. Then it means that you don't know what index notation is. So this is the basic that you need to go with in this lesson. Okay? Hopefully I've made this one clear. When you do this question, when you do like this, you are wrong. The correct way is this one, and we get our answer to be 81. Okay, if you want, you can verify this using your calculator. Just punching 3 to power 4, you are going to get 81. But remember, grade 9 we're not using calculator, so we need to know the basics on how to find 81 without a calculator, and this is the way to go. Now let us look at zero index. Zero index. Now, what is an index? Okay, what is an index? Okay, we already looked at what an index is, so this should be a simple answer to a question to answer. What is an index? An index is the power. Okay, simple. An index is the power given. So here we are simply saying that let us look at the power 0. Any number raised to power 0, what is it going to be? So they are saying that any number a, let a be any number other than 0, meaning other than 0, don't put 0 here. Remember we said that an index, the base should not be equal to 0 or equal to 1. So they are saying that any number a other than 0 raised to the index of 0 is equal to 1. So if a number, let's say x to power 0 is equal to 1, any number, be it 100, 200, 300, 100, whatever number, be it z1 itself, be it 2, be it 5, raised to power 0, the answer is always 1. Okay, so this is a concept that you need to master. It is one of the laws of indices. Of course, we shall look at the laws of indices in brief, but this in zero index, you have to know it, because it never changes. Grade 10, grade 11, grade 12, you shall have this concept the same. It will not change. Okay, so now let us have this example. Let us look at the example. Evaluate A, 3 to power 0, B, 2 to power 0 plus 3 to power 0, and D, 1 over 2 to power 0, and plus 3 over 4 to power 0. Now, the interesting part of question C we shall see. Now let us do the solutions here. Let's say solutions. So the solution is number 1, question number A. Question number A, we are simply saying we should evaluate 3 to power 0. Now, this one is a concept, 3 to power 0, any number raised to power 0, the concept, any number raised to power 0, the answer is always 1. Okay, so this one is raised to power 0, the answer is equal to 1. Now let us come to B. What is B? B is simply saying 2 to the power 0 plus 3 to the power 0. What is 2 to the power 0? Any number raised to the power 0 is what? 1. So it means that this will be 1 plus 1. Therefore, my final answer is 2. Okay, that is how you do it. 1 plus 1 is 2. Then we come to C. C, they are simply saying that 1 over 2 raised to the power 0 plus 3 over 4 raised to the power 0. Now, the thing we should always remember is that when we are given anything inside the brackets, it simply means that the power should be equal to this one. So another way to interpret this one, we are simply saying 1 raised to the power 0 over 2 raised to the power 0. Okay, plus 3 raised to the power 0 over 4 raised to the power 0. As long as there are brackets like this. But if there are no brackets, it simply means that if I have, for example, if I have 2x to the power 0, meaning there are no brackets, meaning 2 is not raised to the power 0 here. The only value which is raised to the power 0, it is the variable which is x. So this is simply going to be 2, x to the power 0, we know it is going to, this is x. X is the one which is raised to the power 0. But this one is not raised to the power 0. So it's simply going to be 1. 2 times 1, the answer is simply 2. Okay, that is what it means. So here, everything is raised to the power 0. 3 is raised to the power 0, 4 is raised to the power 0. That's how I've written it here to make you understand. So how do we work out this one now? 1 to the power 0, the answer is 1. 2 to the power 0, the answer is 1. Plus 3 to the power 0, the answer is 1. 4 to the power 0, the answer is 1. Now let's say 1 into 1, we have 1. Plus 1 into 1, we have 1. So we are going to say now, okay, 1 plus 1, the answer is what? 2. Or if you want, you can find the common denominator, which is 1. 1 into 1 is 1. Times 1, it will be 2. The final answer will be 2. So that is how you work out this one. Dear friends, hopefully I've made this clear. Index notation, this is how we introduce it. Okay, this is how we introduce it, and this is how we work out index notation. And the 0 index should be at your fingertip. You should not forget this one because it will be of great value once you reach your grade 10. Okay, so now let us look at the laws of indices. Laws of what? Indices now.